This section is on compound interest. And it's something that's normally done in a computer, but we're going to actually look at the formula and kind of take it apart and then look in your calculator and see how we can use this application of an exponential function. So the compound interest formula that you see at the top of your notes says A equals P times 1 plus R divided by N raised to the NT power. Now let's talk about each of the letters and what it stands for. So the A has to do with the final amount, the amount that you pay if you take a loan, like on your mortgage, or the amount that you would get if it was an investment, which would include your original investment amount plus your interest. The P stands for principal, which is how much you invest or how much you borrow if it's a mortgage, because it can work both ways. The 1 is always a 1. All right. The R is the interest rate, but it has to be as a decimal. So you have to change it from a percent to a decimal. T is time in years. And now let's talk about the N, which appears in 2 places. You'll see it both places there. That has to do with the number of times that the interest is compounded. And we're going to talk about exactly what that means. So for example, let's talk about N here. If it's compounded annually, that would be 1 time a year, so N would be 1. Semi-annually, that would be twice a year, so N would be 2. Okay, so it's how many times per year. Quarterly would N be 4. We could have monthly, where N would be 12. We could have daily, where N would be 365. And then a little later, we're going to learn about continuous compounding. So let's take a look at how a problem is set up and how you enter this into your calculator. We'll look at example 1. It says a credit union pays interest of 8% per annum, meaning per year, compounded quarterly on a certain savings plan. If $1,000 is deposited in such a plan and the interest is left to accumulate, how much is in the account after 1 year? So we're looking for the A. All right, so A is what we don't know. Let's go ahead and list what we do know. The amount invested, which is the principal, is 1,000. R, it was 8%, so as a decimal is 0.08. T, it says it was left in there for 1 year. And finally, the N, it says it was compounded quarterly, so N is 4. So what we have is A equals 1,000 times 1 plus 0.08 over 4 raised to the 4 times 1. Now you can do this in one step with your calculator, but you've got to be a little bit careful. So I'm going to show you the keystrokes to enter this. So you would put 1,000 parentheses 1 plus. Now we want to put this in, and we want to put that in parentheses. So it's going to be inside parentheses 0.08 divided by 4. Close those parentheses. Close the main parentheses. That's that one. And this one. So I have inside parentheses, outside parentheses, and then it's going to be raised to the 4 times 1. And when you do that, you get A equals 1,082.43216. If we round that off to dollars and cents, we would get $1,082.43, which says that's how much you would get back, the total amount at the end of that year. So if you don't want to do it in one step in your calculator, you can do this inside step first and then add a 1 to it and then multiply it by 1,000 and then raise it to the 4th power. But I actually think it's easier just to go ahead and put it all in. So let's look at example 2. It says investing $1,000 at an annual rate of 10% compounded annually, semi-annually, quarterly, monthly, and daily will yield the following amounts after 1 year. In other words, we're wanting to compare the difference between how much you would get back if it was compounded once, twice, 4 times, 12 times, or 365 times. That's the main thing. We're going to redo the same problem over and over again. So we're looking for A. P is 1,000. R is 10%, so that's 0.1 or 0.10. T is 1, but then the N, we're going to do a variety. So let's do it N equals 1. That would be compounded once a year. You would have A equals 1,000 times 1 plus 0.1 over N is 1 raised to the 1 times 1. If you work that out, you're going to get $1,100. That's how much you would get at the end of that year if you invested $1,000 and it was only compounded one time and it was at 10%. That's what you would get. Let's compare that to if it was compounded twice a year or semi-annually. You would still have the same equation except for the N is now a 2 and our N times T would be 2 times 1. When you put that in your calculator, you're going to get $1,102.50. So you only get $2.50 more. But imagine if instead of $1,000, you were investing $10,000 or $25,000 or $100,000. Then that really begins to make a difference. So as you might suspect, if N is quarterly, then they're paying interest on the interest. You're going to see a little bit more. So we put that same thing in, but we change our N to a 4 times 1, and you get $1,103.81. Okay, I'm assuming here you can put this in your calculator. So again, it's growing a little bit more the more often it's compounded. So if you have it compounded monthly, which would be N equals 12, we would have 1,000 times 1 plus 0.1 over 12 raised to the 12 times 1. Now you're up to $1,104.71, and again, imagine if it was a lot more than $1,000, it's going to begin to make a big difference. And if it was compounded daily, we would have A equals 1,000 times 1 plus 0.1 over 365 raised to the 365 times 1. Now you're going to get $1,105.16. So you can see that the more frequently that it's compounded, obviously, the more money you're going to get. But it also means if that was a loan, the more money you're going to have to pay back. This one was an investment, so it can be a good thing, compounding more often, or a bad thing. Looking at the results from this example that we just did, think about what would happen to the amount after 1 year if the number of times that the interest is compounded were increased without bound. In other words, even more often than once every second, if you want to think of it that way. And there's a formula actually for determining that. If it was compounded continuously, that's called continuous compounding. And the formula for that is one of our exponential functions, and that's this. It's the amount is equal to the principal times E raised to the RT. So it's quite different than our other formula for compound interest. So let's look at how that works. It says calculate the amount A that results from investing a principal of $1,000 at an annual rate of 10%, compounded continuously. So in other words, we're just continuing example number 2, but now we're going to use this formula, which is the formula for continuous. Did I spell that right? I think so. Compounding. I'm going to abbreviate. So let's fill in. A equals, the P is 100. Whoops, P is 1,000, sorry. E raised to the R is 0.1, T is 1. So if you enter that into your calculator, you're going to get $1,105.17. We'll compare that to what we had with 365 days a year. It's only a penny more. But remember, that was only $1,000. If it was a mortgage payment and your loan was $300,000, that's going to make quite a bit of difference. If it was an investment, again, the more you invest, the more difference that's going to make. So let's look at example 4. It says if $2,000 is placed in an IRA paying 7% per annum and compounded continuously, then what will the IRA be worth in 20 years? Well, here's our formula. A equals PE to the RT. We're looking for A. The P is 2,000. E is E. R here was 7%, which is 0.07. And the T, it says, is 20 years in part A. So let's fill that in. A equals 2,000. E raised to the 0.07 times 20. Put that into your calculator and you are going to get $8,110.40. All right, now let's look at this a little different way. If you look in your notes, it says present value. This time we're going to start the formula for some future value, in other words, some amount that we hope to have, so we already know how much we want, and we're going to go, how much do we have to invest to make that happen? So we won't be using this formula, we're going to be using the formula P equals AE to the negative RT. That is for continuous compounding, where we're solving for how much do we have to invest, the principal, in order to receive a certain amount that we've determined, or for any of the other compounding, annual, semi-annual, quarterly, whatever. That formula is P equals A times 1 plus R over N. Notice it's almost the same. We just flipped the A and the P, but then it's to the negative NT. So let's take an example. Example 5 says a zero coupon, non-interest-bearing bond can be redeemed in 10 years for $1,000. How much should you be willing to pay for it now if you want a return of 8% compounded monthly? We're going to figure that first. That's part A. So we're talking about figuring it monthly, so we want this formula. So we're going to write P this time is what we're looking for. The amount we want to be able to get back is $1,000. The rate here is 0.08 or 8%. The time it says is 10 years. And N it says compounded monthly, so N is 12. So we're going to plug that into that formula. P equals 1,000 times 1 plus 0.08 over 12 raised to the negative 12 times 10. Put that in your calculator and you're going to get that P is equal to $450.52. What does that mean? It means if you bought that bond and you paid $450.52 and you left it in there for 10 years and it was compounded every month at 8%, you would get back your the $1,000 at the end that you had hoped to earn. So it tells you how much you should spend on that. All right, let's look at B. This time we want to know, what if it was paying 7%, but it was compounded continuously? So now we want this formula. So we have P equals AE to the negative RT. P is what we're looking for. How much should we buy it for now? The amount we want to get back at the end is $1,000 times E raised to the negative 0.07, and we're also going to leave it in for 10 years. So you put that into your calculator and you're going to get P equals $496.59. So you're going to pay a little bit more for it. It's paying less interest here, so it's going to cost you a little bit more to get the 1,000 back. Okay, this is mostly just about plugging into formulas. Let's look at example 6. This one is a little different because of what's missing. It says what annual rate of interest compounded annually should you seek if you want to double your investment in 5 years? Okay, so let's list what we know. We don't know how much we want to get back, but we do know that it's going to be double what we put in, right? 2p. P is what we're going to put in. We don't know what that is. We don't know what R is. We know that T is 5 years, and N, it says it's going to be compounded annually. So how are we going to deal with all of these things that are missing? I'm going to show you. Our formula here is A equals P times 1 plus R over N to the NT. Now let's fill in the parts we know. We don't know the amount of A, but we know it's going to be, we want it to be double what we put in, so we're going to put 2P for the A here. Equals P times 1 plus R is what we don't know. N is 1 raised to the 1 times 5 years. Alright, I can divide both sides by P, and I get 2 equals 1 plus R over 1 raised to the 5th power, or 2 equals 1 plus R to the 5th power. Now, notice what we have. You have to recognize this. This is something that's been raised to a power, so to undo that, I'm going to take the 5th root of both sides. So 1 plus R to the 5th, I'm going to take the 5th root. That undoes that. And we get the 5th root of 2. 5th root of 2 equals, those undo each other, and you have 1 plus R. So R, if I subtract a 1, is the 5th root of 2 minus 1. Put that in your calculator, and you're going to get R equals 0.148698, or R is approximately equal to 14.87%. That was a really different one because of the way you knew that what you wanted was twice what you invested, and the fact that you were missing the R. All right, let's look at example 7. It says, how long will it take for an investment to double in value if it earns 5% compounded continuously? And then how long will it take to triple? So let's fill in. We have an A, a P, an N, an R, and a T. Okay? What do we know about the A? Again, we want it to double, so it's going to be twice whatever we put in. The N is continuously, so that tells us which formula to use. The R is 5%, which is 0.05. And we're trying to figure out how long is it going to take. So this is what we're missing this time, the T. So I'm going to use the formula A equals P E to the RT, because this is continuous compounding. But I know that A is 2P equals P E to the R is 0.05. T is what I don't know. I'm going to divide both sides by P, and I get 2 equals E to the 0.05t. Now think about how we solve that kind of exponential equation. We take the ln of both sides, that undoes it, and I get ln of 2 equals 0.05t. Divide by 0.05. You can do that in your calculator, and you get that it takes 13.86 years to double your money, or approximately 14 years to double whatever you invest, however much it is. If you want to double it, it's going to take that long with continuous compounding at 5%. Now it says, how long will it take to triple? Well, instead of A equals 2P, we're going to have A equals 3P. The other numbers are the same. Okay, so I'm going to have A equals PE to the RT, but A is this time going to be 3P equals PE to the 0.05T. Divide both sides by P. It's the same exact process. 3 equals E to the 0.05T. Take the ln of both sides, and you have ln of 3 equals 0.05T. Divide by 0.05, and we get T is going to take 21.97 years, or T is approximately equal to 22 years. So you can use these formulas to actually do quite a bit in the world of finance. And if that's something you're interested in going into, you would see these formulas again. Of course, you'd be doing it in a computer more than likely.